Hi, I welcome you all for this session. The topic that we are going to discuss is instruction set of ARM7 processor. It defines two separate instruction sets. One is normal ARM state instruction set, which is 32-bit wide, and another type is a thumb state instruction set, which is a 16-bit wide. The features include that all instructions are 32 bits long. Now we are going to discuss only the ARM state instruction set throughout this unit. We are not going to deal with the thumb state. So all instructions are 32 bit long. Most instructions execute in a single cycle, and they can have conditional flags, and it's a load store architecture based instructions. Data processing instructions act only on registers. Already we discussed about this opcode, operand 1, 2 and destination registers. That is 3 operand format. Instruction set can be extended through via coprocessor, and we are having the possibility of thumb instruction set, and for Zazily for Java developers. Now types of instructions. First one is data processing instructions, and second is branch instructions, third is load store instructions, and next software interrupt instructions, PSR instructions, and coprocessor instructions. We will see some basic instructions with examples for better understanding. This is the instruction format. First opcode and then condition flags, and yes along with condition tells that the condition is set. It will be reflected in CPSR register, and next RD is destination register, RN is operand 1 register, and RM is operand 2 register. We will see examples for simple data processing functions and loop functions and logical functions, etc. Now see here, this is the arithmetic operations. First one is add. Operand data of operand 1 is added with operand 2, and ADC along with carry. Subtraction operand 1 minus operand 2, and subtraction with carry operand 1 minus operand 2 plus carry minus 1. And this is RSB is reverse subtraction, wherein operand 2 value is greater than operand 1. To avoid signed value, this operation RSB is very helpful. And next one is reverse subtraction with carry. So this is the computation formula to do these arithmetic operations. See here, subtraction R1 minus R2, and the result is stored in the destination register R0. Reverse subtraction 0 minus R1, operand 2 is greater than operand 1 R1, and the result is stored back in R0. And subtraction with condition flag set. So sub means subtraction, yes means condition flag need to be set. So flags will be updated after the execution of this opcode. So R1 minus 1 and the result stored in R1. Based on the conditional flags, it will be set. Now using the barrel shifter with arithmetic instructions. Barrel shifter is used to pre-process the data, which can be used for shifting operations and rotating operations. Now see, add R0, R1, R1, L as a left shift. How many times? One time. So this is the number of times ls1 hash 1 means number of times. How many number of times we have to do the shifting? So one time you have to shift. What happens if I shift the value 5 one time, and we have to add the content again R1 and store the content result in the R2 R0. So if I shift, see here, if I shift 5 again, it becomes 10, and again you add with R1, you will get 10 plus 5, 15. That is F. So you got this 5. Again you add the same value, you will get 10. If you shift 1, you will get shift this one, you will get 1 left shift, we will multiply by 2. So left shift means multiply by 2, right shift means divide by 2. So 5 into 2, 10, and again you add the same value 5, you will get 15. So in hexacode it is F. So we got this. See here, I implemented in Keel software. Now move is the instruction. The value 25 moved to the R0 register, 47 moved to R1, and both will add, and the result will move to R2. B is nothing but branch. The loop B1 is the loop. So once the instruction comes here, it will go looping condition. So it shows the end of the program. See here, the value moved to R0 47 moved to R1, and after addition 6C, you will get the result. It moved to R2. Now logical operation instructions and XOR, OR, and bit clear operations. These are understandable. See here, R0 value, R1 value, R2 value. If I do the OR operation, what I will get? 0x 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 0x 1 2 3 4 5 6 7 8. So as I said, we got this answer perfectly. The next one, bit clear. What will happen? And a NOT operation for the second operand. Do the NOT operation on the second operand, and after NOT operation on the second operand, second data, the value will be added to the first data through AND operation. See here, bit clear is nothing but data 1 and data 2, which already should undergone NOT operation. See here, 0B 1111, okay, and R2, I will write it here, R1 0B 111, R2 0B, NOT operation you have to do 0 1 0 0, and do the AND 0 1 0 1 OB, which is stored in R0, OB 1010. See, we got the answer. And compare instructions. These instructions are mainly used to update the conditional flags. Okay, so compare, test, and XOR, everything is done. Compare, negated, CMP, CMP is for normal comparison. TQ is for test for equality of the two 32-bit values. TST is for test bits of a 32-bit value. And next one is shift rotate instructions. Left shift and right shift, left rotation, right rotations. So you can see the examples here. So when you use left shift or rotate operations, barrel shifter will come into picture. And next one, load and store instructions. LDR load, STR store, load half word, store half word, load half word signed, that is negative value, load byte, store byte, set register to address. So these are some of the instructions of LDR. Mostly we'll use LDR and STR commonly in all programs. Next, looping, branching and looping. This slide discuss the branch instructions which has loop operations. So branch instructions to call and return from subroutines. To call subroutines, we have to use branch and link instruction. So in this time, this LR register will come into picture. Link register will come into picture. It will hold the address of the main function, and the processor will return to the main function after completing the subroutine or any interrupt. So when it comes, it has to start from the left out instruction. So for continuation, this link register will be used. And already we have seen looping, branch looping. To end the operation, it has to loop at the same statement. In this example, see here, move R0 is equal to 4. We have moved, and BL branch name is fact. Fact is here. It will come to here immediately. Move R3 is equal to 1. Compare with R0. If it is great or less, do some computations. After that, come back to the loop. See here, if after the computation is over, it has to go to loop. It has to come out of the loop and go back to the main function. Otherwise, still it will be in the inner loop till the computation finishes. The same example, one more example is here. Go to fact loop, complete the task. If not yet completed, stay in the same loop, complete the computation, and then you come back to the main function. So this is known as branch loop operation. Examples are given. Please check out the examples from my PPT. That's all about this instruction set. Thank you. We will see in the next session with another topic.